Gear inches, Wikipedia audio. Gear inches is one of several relative measures of bicycle gearing, giving an indication of the mechanical advantage of different gears. Values for gear inches typically range from 20/70 to 125, as in a car. Low gearing is for going up hills and high gearing is for going fast. Gear inches is actually the diameter in inches of the drive wheel of a penny-farthing bicycle with equivalent gearing. When the high-wheeler or penny-farthing was the ordinary bicycle form, the comparative diameter in inches of the driven wheel was an indication of relative speed and effort. A 60-inch wheel propelled a bicycle faster than a 50-inch wheel when both were cranked at the same cadence. The technology of the high-wheeler imposed a natural limit. A 60-inch wheel was about the maximum size that could be straddled by ordinary-sized legs. When safeties replaced ordinaries, chains and sprockets allowed small wheels to be turned faster than the pedal cranks. As a result, a 28-inch wheel could be made to move a bicycle at the same speed as a 60-inch wheel. Such a bicycle was then said to be geared at 60 gear inches and pedaled similar to an ordinary with a 60-inch wheel. Thus, on a bicycle geared at 72 gear inches, one revolution of the pedals advances the bicycle the distance that a 72-inch wheel would in one revolution. Origin of the term. Gear inches express gear ratios in terms of the diameter of an equivalent directly driven wheel, and is calculated as follows. This formula assumes that any hub gear is in direct drive. A further factor is needed for other gears. For simplicity, gear inches is normally rounded to the nearest whole number. For example, suppose the drive wheel is actually 26 inches in diameter. If the front chainring and rear sprocket have equal numbers of teeth, one turn of the pedals produces exactly one turn of the drive wheel, just as if the pedals were directly driving the drive wheel. That combination of gears and wheel is said to be 26 gear inches. If the front chainring has 48 teeth and the rear sprocket has 24 teeth, then each turn of the pedals produces 2 turns of the rear wheel. This is equivalent to doubling the size of the drive wheel, that is, it is like a directly driven bicycle with a 52-inch wheel. That gear is said to be 52 gear inches. A bicycle with a 26-inch wheel, a 48-tooth chain ring, and a cassette with gears ranging from 11 to 34 teeth has a lowest gear of 26 × 48/34 equals 37 gear inches and a highest gear of 26 × 48/11 equals 113 gear inches. For bicycles with 700C wheels, some cyclists quote gear inches based on a nominal wheel diameter of 27 inches, corresponding to the old British tyre size of 27 × 1/4. Strictly speaking, the rolling diameter of a 700C wheel may be significantly higher or lower than 27, depending on the tyre size, e.g. nearly 27.5 for a 700X38 tyre, or just over 26 for a 700X20 tyre. This can be the source of some confusion when comparing gears unless it is clear whether gear inches have been calculated using the actual wheel size or a conventional EAST 27. One way to estimate wheel diameter is to add twice the nominal tire cross-section to the rim diameter. For example, consider a 700C × 23 mm tire, which has a nominal cross-section of 23 mm. 700C wheels have a rim diameter of 622 mm. Hence the wheel diameter is plus 622 mm equals 668 mm, which is equal to 26.3 inches. 26-inch mountain bicycle wheels have a rim diameter of 559 mm. This ignores factors that contribute to the actual rolling radius of the tire and rim together, the vertical deflection of the tire above the contact patch and the difference between the manufacturer's stated size and the actual tire radius when mounted and inflated. Conversion from gear inches and cadence to speed is simple: gear inches multiplied by cadence divided by 336 equals miles per hour. An equivalent system customarily used by continental European cyclists is meters of development, which measures the distance traveled with each turn of the crank. That is, meters of development is calculated as calculating gear inches. Thus gear inches and development differ by a factor of pi times imperial to metric conversion. To convert from gear inches to meters of development, multiply by 0.08. Both gear inches and meters of development are concerned with the distance traveled per turn of the pedals, and are ultimately ways of indicating the mechanical advantage of the drivetrain, but neither of them take into account the length of the crank arm, which can vary from bike to bike. The crank arm is a lever arm. If two bicycles have different crank lengths but are otherwise identical, a longer lever arm gives a greater mechanical advantage. To take this into account, Sheldon Brown proposed a gear measurement system called gain ratio, which is calculated by the distance traveled by the bike divided by the distance traveled by the pedals during one turn of the crank. He argued that it also has the advantage of being dimensionless. Relationship to meters of development. Relationship to gain ratio.